We have gathered quite a bit of source material detailing the really explosive rise of agentic AI. This is technology promising to fundamentally alter how IT organizations manage pretty much every layer of their operations.
That's right. We're talking everything from infrastructure stability right up to large-scale security management.
And these aren't just, small incremental improvements we're seeing. We are looking at powerful new models that mimic high-level human decision-making.
Absolutely. They offer this immense capability for continuous system optimization and real-time problem resolution.
So our conversation today is really laser focused on the genuinely transformative potential of this architectural shift within IT operations specifically.
And what's fascinating about starting here is thinking about the baseline. IT operations are, I think, universally recognized as the absolute foundation of modern business platforms.
They provide those core services everyone relies on: networking, storage, computing capability, the whole stack.
Exactly. And traditionally, success in this highly critical domain has always been meticulously measured by those 5 core metrics: availability, reliability, scalability, performance, and of course, cost efficiency.
Achieving those goals has always relied so heavily on complex interactions between people, processes, and the technology itself.
Right. So our mission today is to understand precisely how agentic AI's inherent reasoning and its robust planning capabilities completely change this entire operational paradigm.
It sounds like we're moving the organization into a future defined by, radical autonomy.
That's the core idea we need to unpack.
Okay, let us unpack this then with a critical and hopefully simple definition for you listening. When we talk about agentic AI, what are we really saying?
Well, we are talking about the first generation of powerful new computational models capable of not just executing tasks, but accomplishing complex, goal-oriented missions.
And crucially, with virtually no human supervision once the objective is actually set. Is that right?
That's the key differentiator. These are systems that mimic structured human decision-making. They can execute intricate, multi-step tasks autonomously, and they adjust their approach as conditions change on the ground.
So our sources reveal 8 key ways this technology is already fundamentally redefining the core work done within IT organizations. It seems like it's significantly speeding operations and strategically cutting massive operational costs. Okay, here is where the technical discussion gets really interesting for me, because the core difference between this new approach and all previous iterations of traditional automation is this crucial concept of inherent autonomy.
Exactly. We're moving away from systems that simply follow a rigid, fixed script. The old, if X happens, then execute Y logic.
Right, that feels very static compared to this.
It is. We're moving toward systems that possess complex reasoning, planning capabilities, and a goal-oriented utility function that allows them to operate fluently across vast interconnected systems.
This shift toward self-directed reasoning, it sounds like that truly constitutes the analytical core of these agents.
It does, and it is genuinely revolutionary for IT support functions. Agentic AI is capable of performing real-time monitoring combined with advanced correlation.
And that correlation extends far beyond what any human team or even legacy monitoring system could possibly achieve.
Precisely. Consider a typical critical production support scenario. A traditional monitoring system might just flag that a database service is unresponsive. That's usually where it stops.
Okay, so you get an alert, maybe a ticket is opened.
Right, but an agentic AI system, it can immediately detect that same unresponsive service and simultaneously correlate all related log entries, performance metrics, network signals, everything across the entire system infrastructure.
And that could be spanning hundreds of servers, multiple cloud environments even.
Easily. This real-time holistic analysis provides instantaneous context. That contrasts fundamentally with older fixed script automation that would only react to a single predefined isolated trigger.
So the ultimate, strategic goal of embedding this level of inherent autonomy is achieving that critical shift to genuinely proactive IT.
It's exactly. Finally moving away from the constant, frankly exhausting firefighting cycle that defines so much of traditional operations.
This proactive capability means that IT teams will experience significantly fewer disruptions overall. Is that the idea?
Yes, and critically, it's not just because they're getting better or faster at fixing things after they break.
It's because the AI is identifying and preventing small, subtle problems from escalating into those catastrophic, large-scale outages.
That's the promise. The ability to autonomously identify system degradation and successfully act to mitigate it before failure occurs is, according to our sources, the single greatest value proposition here.
That seems crucial for long-term stability and overall platform
It
resilience.
really is. And this capability drives us directly into what the sources label Transformation 5, rapid decision-making on infrastructure issues.
Okay, so what does that look like in practice?
The true value of the agent lies in its ability to quickly analyze the current situation, autonomously decide the most appropriate action based on its complex reasoning models.
And then what happens? Does it just act?
Well, it can then either recommend the most effective approach to the human operator for approval, or within certain defined parameters, it can execute it immediately.
Can you give an example of that decision process?
Sure. Imagine a system is experiencing latency. Instead of defaulting to the common, often disruptive solution of just rebooting an entire server, which affects all the services hosted on it.
Right, which can be a very blunt instrument.
Very blunt. The agent might correlate all the data, identify the specific process that's consuming excess resources, and then recommend restarting only that particular service or process. Much more targeted.
That moves IT from constantly reacting to highly visible symptoms toward actively preventing system degradation before any major outage even occurs.
Precisely. And often it only requires a simple approval from a supervising engineer before the remediative action is executed.
Which must drastically cut the time required to stabilize the platform compared to manual investigation and action.
Exactly. Hours can become minutes.
So when we transition our discussion to measurable transformation in IT operations, it feels like we're fundamentally talking about speed.
Speed is definitely a critical metric. It directly impacts both the platform's reliability and, crucially, the overall cost structure of the entire business.
So Agentic AI acts as an efficiency engine here, accelerating core processes and providing quantifiable improvements, things like delivery cycle times and that absolutely critical metric of mean time to resolution, or MTTR.
Let us analyze Transformation 3 then, focusing on faster problem resolution. This perfectly illustrates the difference between traditional systems and these autonomous agents.
What's the key distinction we should focus on?
The fundamental shift is moving from having an issue merely result in a ticket being automatically created, which is old-style automation, to having that issue automatically resolved.
Okay, that's a huge leap. How is that achieved?
It's achieved through what is called closed-loop execution. Think of the steps involved here. An agent is instructed to constantly monitor crucial service-level objectives, or SLOs.
Those define the acceptable performance thresholds for a service, right?
Correct. When an SLO dips below that threshold, the agent immediately correlates all relevant logs and metrics in real time. It proposes the optimal fix based on its training and current data.
And here is the important technical detail you mentioned earlier. It runs a canary test on the proposed solution first.
Exactly. That distinction needs emphasis for you listening. A traditional deployment requires extensive manual testing and approvals before rollout, which takes time.
Right. So can you elaborate on the significance of that canary test and how the agent uses it to achieve such immense speed?
Absolutely. For those perhaps less familiar with SRE, site reliability engineering terms, a canary test involves deploying the proposed fix to a tiny, isolated subset of users or infrastructure first, maybe just 1% of traffic.
So you can monitor its immediate impact in a controlled way before a full deployment.
Precisely. The agent executes this canary test and watches the performance metrics and SLOs very closely in that isolated environment.
And what happens if the test looks good?
If the canary test is successful and the SLO stabilizes or improves, the agent then proceeds to execute the fix across the wider environment, but only within the approved change window, that specific time frame sanctioned for infrastructure alterations.
Okay, that provides a safety net. But what if the canary test fails or the fix makes things worse?
Critically, if the test fails, or if the SLO dips below the acceptable threshold even after the fix is applied more broadly, the agent is programmed to automatically roll back the change immediately.
So this closed-loop system removes the human reaction time delay from the equation, ensuring both speed and safety simultaneously?
That's the goal. It's designed for rapid, safe remediation.
The quantifiable gain for businesses adopting this approach sounds, well, truly immense. Sources suggest adopters can expect the MTTR for common, repeatable incidents to drop dramatically.
Yes, often falling from hours, or sometimes even days, down to mere minutes, or in the case of simple things like service restarts, literally seconds.
That's incredible. And there's a secondary benefit too, right, regarding postmortems.
Yes, a significant secondary benefit is the ability to conduct far cleaner and more comprehensive postmortems after an incident actually occurs.
How so?
Because every single action taken, whether it was recommended, approved, or executed automatically by the agent, is meticulously logged and recorded with timestamps and context.
Which removes all the guesswork from the root cause analysis process later on.
Exactly. It greatly accelerates the learning cycle and helps prevent recurrence.
Okay, we must also pivot then to Transformation 6. This involves radically streamlined software testing and quality assurance cycles.
Right. Agentic AI is rapidly advancing everything from the efficiency of test case generation itself to the reliability and comprehensiveness of test automation execution.
Think about the current human burden of exhaustive regression testing. Engineers have to verify that new code hasn't somehow broken old, established functionality. It's time-consuming.
Very much so. This technological shift allows teams to largely shift the entire baseline regression testing workload over to the agents.
How do the agents know what to test?
The agents, having analyzed historical failure data and the current code changes being proposed, can ensure that all high-impact areas and previously known failure modes are thoroughly covered before any deployment is even considered ready for human review.
So the human impact of this shift seems like a massive strategic boost, productivity, and even creative output for the engineering teams.
It really is. When the agents handle the tedious, repetitive work of baseline testing and regression checks, human engineers are now empowered to redirect their focus.
They can concentrate on the truly complex challenges, things like intricate integration testing across multiple systems.
Exactly. And exploring a far higher volume of edge cases that require abstract, creative thinking and deep systems knowledge. Things humans excel at.
Which should accelerate the overall software delivery schedule and significantly improve long-term system resilience.
Correct. Ensuring a measurably higher quality product gets out the door faster.
Let us move now to maybe the highest level of system-level self-management, starting with Transformation 1. This focuses on improved compute resource utilization. That's often a massive operational expense for any large organization.
It certainly is. AI agents provide the ability to continuously assess the current resource usage in real time. This is far more efficient than any previous batch-based or time-scheduled method for optimization.
So the agents are dynamically selecting the optimal instance types, maybe adjusting complex configurations on the fly, fine-tuning scaling parameters.
Yes, their goal is to tailor the infrastructure precisely to the current workload demands, essentially moment by moment, no more guessing or coarse-grained adjustments.
It is essential then to connect that granular resource utilization capability back to the overall proactive monitoring framework we discussed earlier.
Absolutely. Think of an agent constantly monitoring data flow, the ingress, the access patterns, usage spikes, egress requirements, all of it.
And it applies sophisticated policy-based principles to immediately detect anomalies in that flow.
That's right. But what's fascinating here is that the agent doesn't just raise an alert about an anomaly, like, say, underutilized storage capacity or an improperly sized virtual machine.
Okay, what else does it do?
It autonomously initiates remedial actions to correct the imbalance based on pre-approved rules or plays.
So it actually fixes the underutilization or resizing issue itself.
Correct, within defined safety parameters. This guarantees the systems are always utilizing optimal resources at the lowest operational cost. It makes the infrastructure incredibly responsive.
And it potentially eliminates the common practice of massive over-provisioning just to cover rare peak loads.
Exactly. That over-provisioning is a huge source of waste for many companies.
Now we should shift focus to Transformation 2, automated support. This sounds like a development that is much more sophisticated than simply replacing a human with a basic script-following chatbot.
It absolutely is. This agent-driven transformation requires IT professionals to shift their focus. They move from executing support tasks themselves to crafting and meticulously teaching the most helpful possible support agents.
So the humans become the trainers and designers of the support system.
Precisely. These agents are trained to perform specific functions, ensuring not only lightning-fast resolution speed and massive scale, but also airtight security and proper change control throughout the entire process.
This move seems like it has the potential to drastically streamline how all operations are conducted across the entire IT landscape.
It really does. A great tangible example of this self-management capability can be found within the world of site reliability engineering, or SRE, practices.
Okay, how would an SRE team use this?
An SRE agent can be tasked with a complex, recurring mission. For instance, ensuring that a massive fleet of servers is constantly maintained, patched according to policy, and consistently kept up to date with the latest configuration standards.
That alone sounds like a huge time saver.
It is. But beyond simple maintenance, the agent can perform root cause analysis with unprecedented speed. It can adjust large amounts of operational data immediately, cross-referencing thousands of parameters and recommending continuous environment optimizations.
So it moves fundamentally beyond traditional IT automation, which really relied on those predefined playbooks for specific scenarios.
Exactly. This moves to a new level of velocity, resulting in drastically reduced cycle times for everything from vulnerability remediation to large-scale system adjustments.
We are apparently already seeing substantial early commercial value in Transformation 4, which is improved customer support. This seems to demonstrate the commercial viability and immediate return on investment of this autonomous approach.
Just right. By coordinating multiple specialized agents to seamlessly coordinate and share information across various complex interconnected systems, companies can resolve complex customer inquiries much more efficiently than ever before.
Can you give an example of that coordination?
Sure, a single customer support issue might trigger coordination between, say, a network agent, a billing agent, and maybe a database agent to gather all the necessary context simultaneously.
Instead of a human support agent having to query each system manually or wait for responses.
Precisely. This rapid execution and integrated resolution capability leads directly to a demonstrable increase in overall customer satisfaction. It proves the value of operational optimization through improving internal system fluidity. We arrive now at perhaps the highest expression of autonomous operations, introducing the ultimate vision articulated in the source material. Transformation 8, the development of truly self-healing systems.
Self-healing systems, that sounds like the holy grail of IT operations.
It kind of is. Agentic AI is emerging as the critical backbone of what we are calling the self-healing enterprise. This is where critical systems are not just monitored for degradation and issues.
They are completely self-managed and self-remediated by the autonomous agents themselves.
That's the vision. It represents the pinnacle of operational efficiency and reliability.
The sources offer some specific, almost jaw-dropping anecdotes that illustrate this future state.
They do. Picture the scenario unfolding. An AI agent spots a subtle, maybe slowly developing memory leak in a critical production server. Very hard for humans to catch early.
Okay, what happens next in this scenario?
Immediately, the agent spins up a fully patched, compliant replacement server in the background. This happens without any human intervention.
Wow. And the traffic.
It seamlessly redirects all workloads and network traffic to the new, healthy node. Then it safely isolates and patches the faulty node for later human analysis if needed.
And this all happens before anyone in the human operations team even receives an alert that there might be a potential issue.
That's the ideal. This rapid, invisible detection and recovery process means that service interruptions effectively cease to be sudden crises requiring urgent human response.
Which results in consistently stable service levels across the entire organization, dramatically changing the user experience for the better.
Exactly. And this radical increase in system stability directly facilitates Transformation 7, enhanced team productivity.
Because the endless Tier 1 grind that often plagues highly skilled engineers just fades entirely into the background.
That's the idea. We are talking about the elimination of the repetitive, low-level tasks. Things like simple reboots, password resets, closing obvious false positive alerts, initial triage of known documented issues.
All of which can be resolved automatically and autonomously by the agents.
Right. This frees up vast quantities of human time and cognitive load, enabling staff members to redirect their focus toward far more creative and complex endeavors.
Tasks that actually require uniquely human critical thinking and problem-solving skills.
Precisely. The new focus for engineers becomes entirely strategic. It shifts their core purpose away from reactive fixing.
So they are now free to concentrate on strategic improvements, like advanced platform architectural design, maybe complex model tuning for better agent performance.
Exactly. And pursuing creative engineering projects that enhance long-term system resilience, improve cost efficiency, or boost user satisfaction in novel ways.
This sounds like a fundamental change in the core mission of the IT professional, elevating them from system maintainers to system architects and trainers of this next generation of autonomous infrastructure.
It really is a significant shift in role definition. However, we must address the implementation reality here by outlining the crucial prerequisites for actually achieving this success. It's not automatic.
Right, it sounds great, but what needs to be in place first?
To unlock the maximum strategic value from agentic AI, The system must be meticulously built on a robust enterprise AI platform
Why is that underlying platform so essential?
because it offers the necessary orchestration capabilities,
Hmm.
secure data access to system logs and metrics across the board, and the core automation layers upon which the agents rely for their analysis and execution decisions.
So without this foundational stability and data access, the agents simply cannot function autonomously or safely.
Right. They need that structured environment and reliable data feeds.
Leaders are wisely advised then to approach implementation using a strategic and heavily phased method, starting small and gradually building up.
Definitely. The recommended path is focusing on localized projects first that demonstrate a clear, measurable proof of value.
Like maybe optimizing a single storage cluster first or automating the remediation of just one common type of support ticket.
Exactly. This phased adoption helps human teams become operationally comfortable with the new technology. It also allows the organization to build a strong foundational approach and, importantly, mitigate the inherent risks associated with high autonomy systems.
Okay, let's talk about those risks. We must also spend adequate time introducing the necessary governance and addressing the significant risks involved with unchecked autonomy.
Yes, while agentic AI accelerates workflows and enhances productivity exponentially, it also creates genuinely new and profound risks if not carefully governed by human architects.
You mentioned earlier that the sources noted agents, without proper guardrails, sometimes did things like erroneously deleting entire sections of code or spiraling into self-reinforcing loops. That sounds, frankly, terrifying.
It is a serious concern.
Is the source material suggesting that unchecked autonomy is an active current threat we're seeing now? Or is it more of a theoretical future risk? What's the potential cost of just one of those spiraling automation failures?
That is an absolutely critical question you raise. The sources emphasize that this is an active and current threat observed in early, sometimes poorly governed implementations. It's not just theoretical.
And the cost.
The cost of a self-reinforcing loop can be catastrophic. An agent, convinced it must fix a problem it actually cannot resolve, might execute its rollback and remediation sequence hundreds of times per second.
Which could cause a cascading failure that overwhelms the network or potentially deletes critical data before human intervention can even occur?
That's the risk scenario, yes.
Yeah.
Therefore, without proper governance and exceptionally strong guardrails, which absolutely must be designed and validated by humans, the risk accelerates right alongside the speed and potential benefit.
This emphasis really highlights the necessary shift in human work then. It moves almost entirely to designing the necessary safeguards to manage that inherent autonomy effectively.
You are essentially designing the rules of physics for the AI, setting its boundaries.
This includes establishing meticulous pre-approved plays for agents to execute, defining strict blast radius tags to limit the scope of potential errors.
And implementing robust rollback paths to instantly reverse changes if a service-level objective dips below acceptable levels after an agent action.
Could you clarify that blast radius tag concept a bit more for the listener?
Certainly, the blast radius tag is a crucial safety mechanism. It is essentially metadata attached to a segment of infrastructure, maybe a specific server rack, a particular application stack, or a single geographical region.
And what does that tag tell the agent?
It tells the agent, if you are working on this system, your actions are limited only to this specific tagged component or area. It prevents a local error or misconfiguration from propagating globally across the entire infrastructure.
So the human job is fundamentally redefined. It is no longer primarily troubleshooting the system directly in many cases.
Correct. It is meticulously designing the safety parameters, the security constraints, and the velocity limits for the autonomous systems that do the troubleshooting and optimization.
Okay, so to summarize the core idea for you listening, agentic AI represents a fundamental and, it seems, necessary conceptual shift. We're moving away from simply automating repetitive tasks
Toward automating high-level decision-making and real-time resolution itself.
The overall role of the IT organization fundamentally transforms from constantly fixing things reactively
To strategically designing the self-governing system that autonomously fixes itself, or at least handles a large portion of it.
The true long-term transformation revealed in these sources appears to be the profound liberation of expert human time and attention.
Exactly. By strategically shifting the complexity, the enormous cost, and the significant time burden of reactive maintenance and repetitive operational tasks onto these sophisticated autonomous systems.
The IT organization gains a powerful strategic capacity for true innovation, for advanced platform design, and for proactive problem solving.
Which ultimately drives much better business outcomes, by ensuring unwavering system stability and allowing humans to focus on higher value work.
Now, consider this provocative thought for your own organization as we wrap up. If Agentic AI successfully handles the what and the how of maintaining daily IT stability, reliability, and security, starting perhaps next week,
Uh,
what are the three most complex, creative, and strategically critical problems in your organization that your absolute best engineers could finally stop putting off and truly focus on instead?